Okay, here's where we stopped. When, there's that interval with a 90% confidence level. Right here, your summary. If you go from a 90% confidence interval to a 95, you can see how it covers more. This one covers a little bit more out here to get to the 0.25 than that 90%. So it's a little bit wider, just like I had told you about on the other slide, where I showed you as you get there, it's covering more and more information. Okay. Refer to the application at the beginning of the lesson. Well, here's all the information that we need. Determine the interval of per pupil expenditure such that the probability is 95% that the mean expenditure lies within the interval. Okay, so on an earlier slide, we did the standard error of the mean. I had 1410 over the square root of 100, which gave me 1410 over 10, or 141. Now, we want a 95% interval, and so back here, where I corrected that, 95% interval is a 1.96. Okay? So, what you're going to have is your mean, 6130. On the right-hand side, I'm going to add this 141 times that 95% was the 1.96. On the left-hand side, I'm going to subtract that thing. So, what I am getting, I was hoping I had it out somewhere, but I don't. 141 times 1.96. 141 times 1.96, 276.36. So I have this 6130, and it's going to be plus or minus 276.36. Okay, so if I add that, I'm going to get 6406.36. That's on my right-hand side. And on my left-hand side, I'm going to get 5853.64. Now, don't forget, this is an actual interval. It goes from 5853.64 up to 6406.36. And there is a 95% probability that the real mean of this whole thing lies in that interval that you've got. Okay. The number of miles a certain sport utility vehicle can travel on 1 gallon of gasoline is normally distributed. You are to take a sample of vehicles, test them, and record the miles per gallon. You wish to have a 99% level of confidence that the interval containing the mean miles per gallon also contains the true mean. So the first one we've got is 25 SUVs are randomly selected and tested. From this sample, the average miles per gallon, that's your X, is 22, with a standard deviation of 4 miles per gallon. Determine the sample interval about the sample mean that has a 99% level of confidence. So we're going to do the same thing we did before with your standard deviation of 4. You can divide it by the square root of 25, which is 4 divided by 5, or a 0.8. Okay. Your mean, 22, is going to be plus or minus that 0.8 times, and when you go back here for the 99% level of confidence, it'll be a 2.58. That's what you're going to multiply by. That 8.8 times 2.58. Okay? So that gives you 22 plus or minus 2.064. Okay. So when you add that, that's 24.064, which is pretty easy. Do that. And then 22 minus 2.064, 19.936. So 24, that's roughly 20. So the span there is roughly 4 units between the two of them. You got that width there to cover the true mean. Now, on the next interval, we're upping it to 400 SUVs. I still got the 22, still got the standard deviation of 4. So we're still doing the same thing, but it'll be the 4 divided by the square root of 400, which is 4 divided by 20, or 1/5, which is 0.2. So in this case, you've got 22 plus or minus the 0.2 times, and again, it's that 99% level of confidence, so it is still from the chart 2.58. Okay, so we still have the 2.58. This time, with it being 0.2, though, it's times 2.58. It's only 0.516. So this is 22 plus or minus 0.516. This means your interval has shrunk dramatically. Okay, 22 plus 0.516, 22 minus, so we get 21.484. So that interval has shrunk dramatically. 22.5 minus 21 point roughly 5 means your interval went down from 4 units to 1 unit. So you have narrowed it down quite a bit by increasing your sample size, which is what this tells you. By increasing the number of items in the sample, but with the same confidence level, the range decreased substantially from about 4 units to this, or about 1 unit. So you definitely narrowed in on containing the true mean. And here's your summary. Increasing the sample size causes the error bound to decrease, making the confidence interval narrower. Decreasing the sample size causes the error bound to increase, making the confidence interval wider. Okay, so that is the effect you've got changing the sample size. I'm going to stop here because that's about 8 minutes, and the last video we've got will cover the last bit of information.